Hello students, good morning. Welcome to this lecture. This is the lecture number 2 on solution. Before going to discuss on this relevant topic in this lecture, let us some recap on the previous lecture, that is lecture number 1. In the lecture number 1 on solution, we have discussed about the types of solutions, that is gaseous solutions, liquid and solid solution, and we have understand different varieties of the solutions by differing the different solute, and also we have understand different example. Secondly, we have discussed about how do we able to describe the concentration of the solutions, that is the compositions of the solutions. And in this lecture we are going to discuss some important relationship, like what will be the relationship between the mole fraction of the solute and the molality or molarity, or third relation that we are going to discuss, that is the relationship between the molarity and molality, that we are going to discuss in these lectures. So first we are going to discuss the relation between the mole fraction and molality. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So mole fraction, that is, we know this is basically, let us understand what is mole fraction. Mole fraction is, that is, number of moles of solute. Here we are considering the mole fraction of solute, number of moles of solutes and total moles. And it is being represented, mole fraction is X2. Molality is basically, it is the molality, we know, molality is, molality we can say the number of moles in 1 kilo of solvent. Number of moles in 1 kilo of solvent, it is the molality. So here molality, number of moles of solute. So here from this molality we can able to know about the moles of the solute. So from this molality we able to know the moles of solute. This is smaller, but we have to calculate the moles of the solution also, moles of the solvent also, because total mole is basically moles of solute plus solvent. So moles of the solvent, how you get that? We know in 1 kilo of the solvent, these moles of the solute is present. So now, and one thing that we have to assume that the molar mass, यहाँ पे molar mass of solvent, molar mass of solvent is suppose M1. Molar mass of the solvent is M1. So moles of solvent, because it is 1 kilo, so we know mass given divided by the molar mass will be its moles. So here 1 kilo is the mass given and its molar mass is M1. So we get that moles of the solute is M and moles of the solvent is M1. So total moles is equal to, that is small m, that is molality, divided by 1 by M1. M1, that is the molar mass of the solvent. So we get this volume by this 1 divided by M1. So here mole fraction, we can understand mole fraction of solute, X2. This is the moles of the solute is small m divided by the small m plus M1 plus 1 by M1, and it will going to give small m by capital M1 divided by small m M1 plus 1. That is the relationship. So we take the relationship X2, that is the mole fraction of the solute, is equal to small m1 by small m1 plus 1. This is the relationship. So what is the relationship? That is the mole fraction, and we get this value, we get this expression, that is small m is molality and capital M1 is the molar mass of the solvent, and we will get in the exam that will be very helpful to calculate. Sometimes you have been asked to calculate the mole fraction of solute. You have been given all this information, then you can able to easily calculate. Now we are going to discuss the relationship between the molality and molarity. We know molality expressed with small m and molarity is capital M, and you have been given the solution, density of the solution, is D, and molar mass of solute is equal to M2. Here you have to derive what will be the relationship between the molality small m and molality small m and molarity is capital M, giving the density of the solution D and molar mass of the solute M2. So we will start from the definition of the molarity. What do we mean by molarity? Molarity means molarity. Molarity means number of moles, that is M moles. Where molarity M means there is a M moles of solute, M moles of solute present in 1 liter of solution. moles of solute present in 1 liter of the solution. So from this we can see mass of solute we can say that is M2 into M. This is the mass of the solute. Now mass of solution we can have, suppose D is kg per liter. This is kg per liter. So if D is kg per liter, at that time we will say this is suppose kg per liter. So what will be the mass of the solution? The mass of the solution will be D. So mass of solvent is how much? Mass of the solvent, that will be D minus M2 by M, and this is in kilo. So here also M2 also kg, molar mass in kilo. So we get this expression. So we know molality. What is the definition of the molality? Molality का definition क्या है? What is the molality definition? Molality M means M moles of solute. M moles of solute in 1 kilo of solvent. So in this solution there is a M mole. M, that is represented by the molality. So we can transform this expression to the molality. So we can write M is equal to number of moles in the solution is, we know already, that is a capital M, divided by mass in kilo, the D minus M2 by M. So this will be the relationship between this molality and molality. This is molality and this is molality. Now one question is, suppose you have given 1 mole solution and 1 molar solution and 1 molar solution. The 1 molarity of the solution and 1 molality of the solutions. Which will be the more concentrated? 1 molar solution or 1 mole solution, that is in the aqueous solutions, that is in water. What will be the more concentrated? More concentrated. More concentrated will be the 1 molarity, that is 1 molar solution. We can write 1 molar solution is more concentrated than 1 molar solution. How? Let us understand. In 1 molar solution, that is, we understand M is equal to the number of moles of solute divided by 1 liter of the 1 liter of solution. And in this solution you can understand that it contains both the solute particle as well as the solution particle. So here what is going to happen, the amount of the solvent will be less than 1 kilo, because the density of the solution, density of the water is 1 gram per cc. So here in case of 1 molar, if we replace this by 1 solvent, weight of the solvent, we will find it will be less than 1000 gram. Whereas in molality, we can find the number of moles divided by your 1 kilo of solvent. So here you can see this is more concentrated because the solvent is less. In case of molality, solvent is less, whereas in the molality, solvent is 1 kilo. So it will be more concentrated. Okay. Next we are going to understand the relationship between the mole fraction X2 of solute, mole fraction of solute with molarity. You have been given number 1 density is given d kg per liter, molar mass of solute and solvent is given M2 and M1. So these two things we have given. I have to calculate the relationship, because in the previous we have calculate the mole fraction of the solute between the mole fraction solute and the molality. Now here the mole fraction and the molality, that we are going to discuss. So from the very definitions that we proceed, that is the M1, when you say molality means what? Molality means M moles of solute in 1 liter of solution. This we already know by definition. And here 1 liter of solution means what? 1 liter of solution mass is d kilo, because its density is d kg per liter. So what will be now mass of solute, that is, we get d into M2. Mass of solute is d into M2. This is M. The moles of the solute is M and is molar mass as M2 will get. Then mass solvent, mass of solvent, that is naturally D minus M into M2. So we get the mass of the solvent. So from this, moles of solvent, how much it is? It is mass, this is the mass in kilo, minus M into M2 divided by molar mass of the solvent is m. So total moles, naturally the moles of the solute and moles of the solvent. So we get moles of the solute is capital M plus moles of the solvent is D minus M2 by M1. So we get from this small m, capital M1 into small m plus D into M2 divided by M1. So the total mass, total moles. So mole fraction means what? Mole fraction that is X2 is equal to mole fraction of solute. X2, that is being given here. Number of moles of solute divided by total moles. We just put all this value that we have calculated. Number of moles of the solute is M divided by plus D minus M2 by M1. So we get this expression M into M. We are just rearranging it plus D. This will be the expression. X2 will be this. This is the final result. Okay. Suppose you have been given two solutions. One solution having normality is M1, volume is suppose BCC, and is normality is M1, N1. And another solution that is, it is volume B2cc and is normality N2. When we mix these two solutions, what will be the normality of the resultant solutions? Suppose this normality of the resultant solutions is N3, then we can calculate this by this formula. That is N3, that is the resultant normality of the resultant solution will be given by N1 B1 plus N2 B2 divided by B1 plus B2. And same thing will be applicable for the molarity also. Suppose the two solutions having the different molarity, that is M1 and M2, and its volume is V1 and V2. Then also we have the molarity M3 will be given by the M1 V1 plus M2 V2 divided by V1 plus V2. So this is the two very important relationship. Okay. Now we do some numericals. One very simple numerical I am going to give you. That is, suppose there is a solutions of BaOH, barium hydroxide. Its solution is having the 0.5 liter and its mole is molarity is, suppose, that is 0.003 molarity. Calculate the moles of OH minus iron. The option is given here 0.003, one option. Second option 0.0015, third 0.0075, and fourth none of above. Solution of BaOH having 0.5 liter and its molarity is 0.003 m. We have to calculate the moles of the OH minus iron. How do we calculate? Let us see. For that, you have to first find out the moles of BaOH, and that is we given very simple thing, that 0.5 into 0.003, and it will be coming around 0.0015 moles. And 1 mole of BaOH, barium hydroxide, will produce Ba2 plus 2 moles of OH minus iron. From this reaction you can be able to say. So moles of OH minus will be, that is 2 into 0.0015, and that will be coming around 0.0030. This will be the answer. So this will be the answer. So that is all for today's lecture. In this lecture we have discussed about some important relationship between the mole fractions of the solute and the molality, and also the mole fraction of the solute with the molarity. And also you have discussed the relationship between the molarity and molality. And also we have done a very simple example how this type of questions, which type of questions that may arise in the exams. So that is all. In the next video we will discuss about another very important thing in this your selection chapter. Thank you very much for watching.